this is Mrs. Cribb, and this is a review of significant figures and scientific notation. You might want to take a couple of notes, but if you don't, that's fine. You just need to make sure you remember all of this stuff. Remember, first of all, the Atlantic-Pacific rule, and with the Atlantic, you have to figure out if the decimal point is absent, and with the Pacific, is the decimal point present. So P for present, A for absent. And then if it's absent, you're going to come in from the Atlantic. This is my crude drawing. And you're going to move until you hit the first non-zero number and then count. If it's present, you're going to come in from the Pacific and move from the left until you hit the first non-zero number. So let's look at this first one. The decimal point is present, so we're going to come in from the Pacific. We go straight through until we hit the first non-zero number. There it is. And now we count significant figures. 1, 2, 3. This one has 3 sig figs, okay? How about this one? That it's also present, so we come in from the Pacific. The very first number is non-zero. So 1, 2, 3 sig figs here too. Now, the difference between this one and this one is this one had some leading zeros. And remember, leading zeros are losers. Leading zeros are losers. You don't count those. All right, what about this next one? This one is in scientific notation. And when you do that, you only look at this portion of the scientific notation. There's always going to be a decimal point when you have scientific notation. So it's present. You come in from the Pacific and you count 1, 2, 3, 4 significant figures. Every number after you hit the first non-zero number counts. So the zeros after the first non-zero number do count. Okay, now we're going to hear this one's absent. So you're going to come in from the Atlantic and you go through the zeros. You hit the first non-zero number and it has 1 significant figure. And this one, it's present, so we're going to come in from the Pacific, hit the first non-zero number and count 1, 2, 3, 3 significant figures. And I want you to notice here, this is the number 100 and this is 200 with a decimal. That decimal made all the difference. The 200 has 3 sig figs and not 1. Let me go ahead and do at least one more from the absent. Let's see. This is a really large number, and of course it has to have a unit. It has to be a measured value to have significant digits. Now it's absent, so I'm going to come in from the Atlantic. I'm going to go straight through all the zeros and count 1, 2, 3, 4, 5, 6, 7. This one would have 7 significant figures. Okay, you need to remember significant figures when you're doing your calculations and how to use them. So a lot of times we're on this particular chapter, we're going to be converting stuff. Like maybe I have 21.06 grams and I'm going to turn it into moles. And so to use that, I'm going to need the molar mass. To go from mass to moles, I need the molar mass. And let's say this is nitrogen. And so I know the molar mass of nitrogen off the periodic chart. And the molar mass of nitrogen has an atomic mass of 14.01 AMUs. And so the molar mass then is 14.01 grams. I get this number straight off the periodic chart. So 1 mole weighs 14.01 grams, or technically masses out to 14.01 grams. This is the ratio right here that I have to use. This is a ratio. Remember, I can do 1 mole over 14.01 grams or 14.01 grams over 1 mole. There's 2 ratios, and I choose the one that's going to work for my situation. And in this case, I need the grams to cancel, so one has to be in the numerator and one in the denominator. Cancel out, and then I pull it up, and I'm going to have some kind of answer. Let me pull up my calculator now. I want you to pay attention to what I'm doing in the calculator. This one's easy. Turn it on first. 21.06 divided by 14.01. It's 1.5032. I'm going to write a lot. 1.50321. Okay? So 1.50 0321. Now I wrote more significant figures than I need. So now I have to check. You determine your significant figures by the measured value, which is this value here. This was a definition. This is what I got off the periodic chart, so it's not measured. This was measured, and it has a decimal place. Come in from the Pacific. It has 1, 2, 3, 4 sig figs. So I need 4 sig figs into my answer. 1, 2, 3, 4. That's because we're multiplying and dividing. When we multiply and divide, we count the number of significant figures. Remember, the rules are different for adding and subtracting. So I need 4 significant figures. I look at the next number to determine that what to do with this one. The 3 is going to stay a 3 because 2 is less than 5. If it's 5 or greater, we're going to round up. So we leave it, and it's 1.503 moles. That's how many moles of nitrogen I would have had in this particular thing. Now let's try with scientific notation, because we got to deal with scientific notation. First, let's review. If we have a number like 202.17, I'm making something up here, and I want to turn it into scientific notation. Well, the decimal would be right here at the end. And so I want the decimal to get to this spot right there, because you should only have one number, only one number to the left of this decimal. So I'm going to move it 1, 2, 3, 4 places. So I would change this to 2.0217. So there's only one number right there. And times 10. And I moved it 4 places. 1, 2, 3, 4 places. So times 10 to the 4th. Okay, when you have a number greater than 1, 20217 is much greater than 1, then you're going to have a positive number, and it's going to have a positive exponent up here with the 10. Remember how the number line works. This side would be a positive side, and that's the negative side. Okay, keep that in mind, because if I want to turn a number back to standard notation, I look and see that it's positive, and so that means I'm going to move my decimal to the right. I'm following the number line. The number line goes right when it's positive, so I'm going to move my decimal right. So I'd move it, here it is, 1, 2, 3, 4 places because of the number 4, to go back to 20217 as my number for scientific notation going to standard notation. Another thing I want to point out, is when you're figuring out sig figs for scientific notation numbers, this is where you get the sig figs from, not from this portion. This portion is important because that shows you what the number really is, but this is where the sig figs come from. So this number has 1, 2, 3, 4, 5 significant figures. It would have been completely, well, not completely wrong, but it is wrong to move your decimal to there and to say 0.20217 times 10 to the 5th. That's wrong. You have to have one number to the left of the decimal. Okay? Now let's look at another number that's, let's say, a tiny number, because we're going to deal with lots of small numbers. Okay, and we're going to turn this number, maybe this is the number of moles, or which is not, it could be. So we're going to turn this number into scientific notation because this is just really awkward to write. So again, I want to move the decimal from here to right here. I want it to be where the green part is. So I'm going to move it 1, 2, 3, 4, 5 places. Okay, so 7.001. I'm going to write this like this for a moment. Okay, yeah, times 10 and to the negative 5th, because this number is much less than 1. This number is less than 1, so when it's less than 1, you're going to have a negative exponent right here, the negative 5. Okay, when it was greater than 1, up here you had a positive exponent. Less than 1, you have a negative exponent. Okay, now how many significant figures did the first number have? Well, the decimal place is present. I'd go straight through here and I'd count 1, 2, 3, 4, 5, 6 sig figs. Well, does this still have it? 1, 2, 3, 4, 5, 6 significant figures. Yes, it does. It has 6 significant figures. Again, I should have written moles because, the only way it has sig figs is to have a unit. I'm going to do one more with scientific notation. And this many grams, I'm going to turn it into scientific notation grams. Okay, so the decimal would have been here, but it's not really there. Okay, let's first figure out how many sig figs this guy has. The decimal was absent. Let me erase the decimal for a minute just so that you remember what it was like before we got started. The decimal is absent, so we go through it and we count 1, 2, 3. It has 3 sig figs. It's a 3 sig fig number. The original answer has 3 sig figs. Now let's turn it into scientific notation. The decimal was here. We move it 1, 2, 3, 4 places. So it's 2.36. I'm going to write this for a moment. Times 10. Since this number is greater than 1, we're going to have a positive exponent. So 10 to the 4th. Okay. Now this number is not completely correct because the original number only has 3 significant digits right here. So I only need 3 significant digits right here. That means these zeros should not be there. Those trailing zeros did not matter. All they did was put the 6 in the hundreds place. I don't need it over here. So this should only have 3 significant digits. So the correct way to write this was really 2.36 times 10 to the 4th grams. Okay? All right. Now I'm going to do just a little bit more, so just 1 second. Clean it up a little bit, and what I want to do is a typical calculation with scientific notation. So let's say that I have 7.863 times 10 to the 33rd moles. No, not moles. Let's say atoms of carbon C. And I want to turn that into moles of carbon. Okay, so I'll take my scientific notation number, my number of atoms. And if you have a number of atoms, it is going to be a large number like this because atoms are so small. That's what I know for sure. I use my bridge notation. And since I'm turning atoms into moles, 1 mole goes on top, and the number of atoms in 1 mole goes in the bottom. Well, how many atoms are in 1 mole? That's Avogadro's number. Remember that? 6.022 times 10 to the 23rd things in 1 mole. So there are 6.022 times 10 to the 23rd atoms in 1 mole. This is the conversion factor. I'm going to start using CF for conversion factors sometimes just to help you understand what it is. All right, so now what I do is I cancel out atoms, and I end up with a unit of carbon moles, and that's really what I wanted. I just wanted to know how many moles it is. So I'm going to now pull up my calculator and do this math, and I want you to follow carefully. Oops, that's not what I meant to do. Go back to there. Pull up the calculator. There it is. Carefully follow how I enter this in. So down here, look down here, where you just write in the number or type it in, 7.863. And this is where I really want you to follow my example. Second function, there it is. And the double E is the second function points you to the yellow stuff or the purple or blue, whatever your calculator color. It's the comma above the 7. It's really the EE. And that stands for the exponent. What is the exponent of the number 10? The exponent here is a 33, so I enter in a 33. And I usually say enter. There's my number in scientific notation. It's over here, 7.863 times 10 to the 33rd. 7.863 times 10 to the 33rd. Now it's on the bottom, so I have to divide. So divide by 6.022. There's that second function, the double E, where it has the comma, and 23, because that's the number that we're going to use a lot as Avogadro's number. Enter. So there's my final answer, or my raw answer without changing sig figs. 1.30571. Okay, let me write that down. 1.30571 times 10, and I forgot what the exponent was, times 10 to the 10th, times 10 to the 10th. 1.30571 times 10 to the 10th. Okay, now I'm going to evaluate for significant figures. This one has 4 significant figures right there in the measured value. This is not measured, this is a definition. I need 4 significant figures, 1, 2, 3, 4. So I'm going to write, I'm using a lot of colors, aren't I? I'm going to write my answer with up to the 5, and I have to look at the next number. The next number is a 7. The 7 says to round that 5 up, because if this number is 5 or greater, the number you're rounding goes up. You only round to one spot. You only look at one spot. So this becomes 1.306 times 10 to the 10th. And the unit is carbon and moles. So moles of carbon. That's going to happen a lot. Okay, that's how you use scientific notation and significant figures together. Okay, this is a brief review. If you need more help, you may need to come to a tutor session or go meet with somebody and get a little bit of extra practice. See you soon.